Hi there, welcome to section 1-2 of geometry. So yesterday or last time we talked about points, lines, and planes. So now we need to talk about measure. Not distance, don't think on a graph, we'll do that later, but measure of lines and segments. So a line segment, remember in section 1-1 I said a line has an arrow on both sides. That's really important. If it doesn't have an arrow, it's something else. So we have to talk about line segments because since a line goes off in both directions forever, you cannot measure it. There is no end on either side. So a line segment can be measured because it's a part of a line with two endpoints. So notice in this diagram, we have line PQ. So line PQ, two capital letters, the arrow over it. We cannot measure line PQ because it goes off to the left and the right forever. However, we could measure segment PQ. So segment PQ is the same symbol. It's the two endpoints, and it's got a segment above it instead of a line above it. So if we're talking about segment PQ, we can measure it. If we're talking about line PQ, we cannot. Sometimes the measure isn't as easy as, oh, that's 6 centimeters or 8 inches or 2 miles. Sometimes it's a bit more talking about just in terms of other segments. So betweenness of points, the word between should give you a clue here. In this particular case, does everybody notice that point M is between points P and Q, right? They are collinear. They are collinear. That's important. So three things we're going to say. First of all, point M, or any point, is going to be between two other points. They have to be collinear. And if those two things are true, then we can say that the whole segment PQ, if we look at its parts, from here to here, and from here to here, make up all of segment PQ. So we could say that PM plus MQ is equal to PQ. Or if you wanted to flip it around, you could say segment PQ is equal to PM plus MQ. Whenever we're talking about segments, whenever we're talking about lengths, we don't put the little segment symbol above it. That's just how it works. We'll do the same thing with angles and other things as well. So the length of PM plus the length of MQ equals PQ. This is a really important statement. I need to make sure I highlight this because we're going to use this geometric statement. This is a geometric statement. It's just a statement in geometry for betweenness of points. We're going to use that. I'm going to ask you in your problems to write the geometric statement before you get to any sort of numbers or algebra or math problems. So the geometric statement, we're in geometry class, right? So I want to see the geometry behind what you're doing. So keep that in mind, really important. So if I asked you for problem number 1, find EG, notice it doesn't have the segment thing above it because I'm looking at the measure of segment EG. You might hop right to your calculator because I know how much everybody loves fractions. But before you do that, write a geometric statement. I'm probably going to say that 100 times, or when I look at your work, I'm going to say, where's your geometric statement? Write your geometric statement first, then do the math. So my geometric statement, if I want to find segment EG, what two parts make up segment EG? Well, if I'm going to highlight like I did before, this piece plus this piece equals the whole EG, right? So that first piece is EF plus FG. Notice these two have to back each other up. They have to be the same point because that's what's in between. So point F is between E and G. They're collinear. So now I can put things in. Think algebra. You know algebra. Do you know segment EG? No. What do you put in when you don't know something? In math, we put an X. EF looks like 2 3/4 to me. FG looks like it's also 2 3/4 unless my eyes are not seeing well. If I do that math, I can just say, well, then segment EG is equal to 5.5. If I'm being technical, I'll put in inches on there. So I need to see the geometric statement, and then I need to see the math problem when you substitute in values. So geo statement, and then I'm going to just call this substitution / algebra problem. That was an easy one. So if we just look at number 2 real quick here, if we're going to find QR, if we don't know, we can put an X there, right? If the first thing I want to always see is a geometric statement, I need to know what two pieces add up to make the whole thing. So it looks to me like PQ plus QR have to equal the whole segment. So PQ plus QR equals PR. Notice I wrote it the opposite this time. It doesn't matter which way you do it. The two parts add up to the whole thing. So it doesn't matter which order you put it. In problem number 1, I put EG equals the two parts. In problem number 2, I put the two parts equal the whole thing. Whatever way you feel best about. I know that your first instinct is probably to just go ahead and subtract. However, I want to see your geometric statement, and then I want to see your substitution in your algebra problem. So PQ is 6 5/8 plus QR is what we do not know, and segment PR is 13 3/4. From here, do what you got to do. When it comes to geometry, show your algebra problem, show your substitution steps with your numbers in place of your geometric pieces. If you want to show minus 6 5/8, minus 6 5/8, you can. If you don't need that, you don't have to show that, because I know that you know how to solve a one-step equation. So when you do that math, you're welcome for the fractions. I believe that comes out to 7 1/8 feet. So hopefully I'm being pretty clear on what work I'm looking for from you. I need to see some specific things, including that geometric statement. I'm pretty picky about that. Let's do problem number 3. I think we can skip 4 because it's a word problem. We're going to find this a lot. And I am going to tell you, you know how I said write the geometric statement first? If you don't have a diagram, I want to see a diagram. So draw a diagram, geometric statement, algebra or substitution. Hopefully you realize when I say substitution, I'm just saying substitute the values in place of the geometric parts, and then your solution. So find the value of the variable if t is between s and u. I need to draw that. It's just a segment, right? So I'm going to draw a segment. I'll put it really off center because people always have a tendency to want to put it right in the middle, but that comes later, so I just want to make sure you see. T is between S and U. So what are the two endpoints of this segment? It's got to be S and U, right? And T is between them. They are collinear. We've got ourselves a setup. If I kept reading, I would have noticed that ST is equal to 7x, so I'm just going to label that. SU, the whole thing, is equal to 45, and TU is equal to 5x minus 3. All right. It does not matter where you put T. If they're not even, if your diagram doesn't end up being the right proportions, things like that, It's just the diagram so you get the idea of what it looks like. So we drew the diagram. We need to write a geometric statement. So remember, geometric statement is what two parts add up to the whole thing. Doesn't matter what you put first. Well, the whole thing is 45, and the two parts have to be, oh, hold on. I just skipped my own step. The whole thing is SU. The two parts are ST plus TU. If you wrote yours as ST plus TU equals SU, you are absolutely 100% right. When you draw a diagram, you should not need the words anymore from the problem. You've got everything you need there. So now, I don't know what happened to me. I had a mind warp there. SU is 45. I can do my algebra, my substitution. ST is 7x, and TU is 5x minus 3. Hopefully you remember how to solve an algebra problem. I'm going to combine my like terms first. 45 equals 12x minus 3. If you want to show plus 3, you can do that. 48 equals 12x. If you need to show divide by 12, feel free. If you don't, that's all right. So that means that x equals 4. Now, the one trickiest part in geometry, we're going to run into this today and from here on out. Go back to your original problem. We know that x equals 4 and see what it asks you to find. Sometimes it'll say, find the value of the variable and the length of st. Blah, blah, blah. Well, we found the value of the variable, x equals 4. Does it ask us to find any other value? Does it ask us to find st or tu? It doesn't, right? If I asked you to find st, could you find it? St equals, well, if x equals 4, we'd simply plug that back in there. When you've got a number and a variable, 7 times 4, it's always multiplication. So if I had asked you for st, you would have told me it was 28. If I'd asked you for tu, you would have substituted a 4 in there. 5 times 4 is 20, minus 3 is 17. And then you could double check, is 28 plus 17 equal to 45? There is always a built-in double check in geometry problems. If your two values of st and tu do not end up being 45, you did something wrong. So go back and double check. All right, so those are my favorite problems. You're going to see a lot of those ones. I feel like we could skip this one. Maybe we'll use that as a practice. Please notice, though, it says to find the value of A and segment XY. So your final answer is going to be A equal, and the length of segment XY is equal to, after you plug that in. Congruent. This is a really big concept. We're going to use this all the time. Congruent means equal. It's two segments with the same measure. Remember, it can't be two lines because we don't know measures of lines because they have arrows on both ends. There is a symbol for congruent. It's an equal sign with a little squiggle on top. Really important symbol. You're going to use that a lot. So, in my little diagram over here, could we say that AB is congruent to CD? Well, they both are marked as 1.7 centimeters, right? They're two segments that have the same measure. They both measure 1.7 centimeters. So we would say segment AB is congruent to segment CD. However, I got a trick for you. Watch out. What if I didn't tell you that those were congruent, that they were 1.7 centimeters? Notice they both have dashes on them, little pink dashes. That is really important. That is the congruent symbol. So, congruent. So either it will write it out for you and say, like I wrote for the example, segment AB is congruent to segment CD, or if it doesn't give you anything, it'll give you those little dashes. Therefore, without any kind of measure, you know they're congruent. It doesn't matter how big they are. I could see a math problem coming into play here because maybe I say, I've got segment EF, and I've got segment GH. And maybe I say, oh, well, all I'm going to tell you is put a couple dashes on each. And I'm going to say that EF is 3x plus 5. And I'm going to say that GH is 2x minus 17. First of all, I don't tell you the actual length. I don't know that EF is equal or congruent to GH, except for these little double dashes. So I told you that these guys were congruent. Well, I wanted you to know that EF and GH are congruent to each other, but not the same length as AB and CD. So it's like a double dash, or I could use triple dashes if I had another pair of congruent segments. And then if you know they're congruent, if you know they're equal, we would be able to set ourselves up a geometric statement. EF is congruent to GH. And then I could do some substitution. It says EF is equal to 3x plus 5. And I could say GH is equal to 2x minus 17. Solve myself an equation, and I get some value of a variable. I'm probably going to come up with the negative. Don't love it, but I just made them up really quick. So be on the lookout for those. It's a sneaky way to throw in a math problem without actually saying a math problem. I could just say find x, or maybe I just say find the length of segment EF. So if I say find the length of segment EF, you have to figure out what x is and then plug it in to figure out the value or the length of EF. So watch for those sneaky questions. We throw them in a lot. Last but not least, determine whether each pair of segments is congruent. So basically right here, what I'm wondering is segment SU congruent to segment VT? It's a question mark. I don't know if they are. But, and notice it says explain. I got to make sure I explain about the explain. So segment SU is from here to here, right? I'll highlight it. What is the length of segment SU? Well, it's S to the cross or the intersection, and then the intersection to U. So it looks like it's a 4A plus A. What if I want to find the length of VT? Well, from V to the intersection and then the intersection to T. So that looks like it's going to be a 2A plus a 3A. Are those guys congruent? Well, this would be 5A. This would be 5A. So yes, they are congruent. Well, I'll say it this way. Yeah, I'll say yes. SU is congruent to VT. And your explain is this. That's your explanation. You don't have to write me a book. You don't have to write me a sentence or a paragraph. If you give me your work that shows me that you knew what to look for, that is an explanation. So a lot of times in geometry, an explanation is a work set so that I can see that you knew what it was that you were looking for. All right, so we talked about congruent, we talked about betweenness of points, and we talked about writing your geometric statement for betweenness of points, and also for congruent segments. You can write a geometric statement. So that's the end of section 1, 2, and we'll talk more about this. Thanks for being here.